All right. Hello, everyone. Um, this is the final section from Chapter 1. This has to do with weighted elections. Okay, so what is a weighted election? A weighted election is a situation in which each voter has an unequal share of the total votes. Um, there are a lot of situations where this can happen. Um, Essentially, this happens anytime where one party um, is given one or several votes that represents some unequal group. Um, so an easy one would be like stockholders of a corporation. More investment means more say in the company's operations. So like the CEO might own, 40% of the company. And so, if there are, let's say there's a million stocks out there, right? So if there's, say, 1 million stocks for a company available, let's say, a big tech company, right? Or whatever company, let's say there's a million shares of stock available. Now, the CEO might have 400,000. And if it's a system where like you need a majority, the stock, the CEO might have 40% of the say. Um, and so he'd only need a few more people, big people to pass some um, resolution with, 500,000 votes. Or what if he votes no? Then, a whole bunch of little people like you or me who might buy, a few shares of a company at a time, say 5, 10 shares of a company. Say we might have that, and but there's a lot more of us. And if all of us feel a particular way, we could override the CEO, but that would take a lot of people. And that's how this kind of system is designed. One person with a lot of power, a lot of say, can make a decision, but can be overridden by um, a popular opinion, and vice versa. Okay, another good example is the Electoral College. Even though technically each voter or each elector within each state has their own say, um, generally speaking, um, each of the states, most of them, 48 out of the 50 states, or really I should say 49 out of 51 locations, um, hand out their votes en masse. So like if, Democrats win California in a popular vote, and all 55 votes um, go to Cal. All 55 electors will vote for the Democratic candidate. And same thing for Texas or New York or Florida or any of those. The only states that do it differently are Nebraska and Maine, which split by district. Um, I personally think everybody should do that, but um, that's not what we do right now. So 49 out of the 51 do that. Nebraska and Maine are the only ones that split by district. Um, so let's see. In this type of election, we're going to focus on the idea of voter power. Um, and so we wish to know, given a certain situation, how much power does a voter actually have? Um, Sometimes a voter has all the power, sometimes a voter has no power to influence the outcome. It would make sense if the voter's power is proportional to the number of votes they hold, but it turns out that that's not necessarily true. And that's very important to do this because you start to see some patterns in the numbers and like how many votes does a person really need versus how many they have, right? So let's take a look at a couple situations. Okay, first off, some vocab. Um, The weight is the specified number of votes that a voter has. For example, the Electoral College, Connecticut has a weight of 7. Um, that means that our vote counts as 7 points. Um, Even though Connecticut is considered as having one outcome, it has a weight of 7 because it is 7 people that have come together to vote a particular way. So you're going to see this notation a lot more. You're going to see the first line. So P1, P2, P3, and those are going to represent people or voters. And we'll usually deal with numbers, but in case you need it, W1, W2, W3 represents their weights. Okay. Just some simple vocab related to government stuff here. So a motion is a yes or no vote on an issue. And that's really what we're considering. So these kinds of elections are only good for questions that have a binary outcome. Do you wish to build a bridge or do you not wish to build a bridge? Will you vote for this package or will you not vote for this package? Could be anything like that. The minimum number of yes votes needed to pass a motion is called a quota. A quota won't make a lot of sense unless it is at least a majority. 51% is usually a pretty good quota, but you might also see sometimes numbers like I've seen 55, 60, or even say 67% or 75%. Those are common quota numbers. Some of these you might be familiar with. For example, 75%. In order for an amendment to pass the states, a constitutional amendment, it must be ratified by 75% of the states. So there we go. And they set that number high on purpose, right? And so sometimes votes have to be set that high. Okay, so let's take a look at the way that the notation is going to look. So you're going to see a lot of problems that look like this, and they're going to be in brackets. This is called weighted voter notation. So the first number is always going to be the quota, and it's going to have a little colon after it, followed by 3, 4, 5 voters. We're not going to do any more than that because just the math and the organization needed to organize 5 or 6 voters is just too much. So generally, we're only going to do this with 3, maybe with 3 or 4. Most of the time, we do it with 4. So in this particular system, we might have 4 stockholders, 40, 30, 15, 15%, and 51 is the quota to pass. So if we build it in terms of percentages, we have this. Now, the data does not have to be in percentages. It could be some total amount of votes that it has, some ratio. So these numbers could add up to whatever. And the quota will be something that is a majority or a little bit more than a majority of the total points available. Okay. So what we're going to do here, essentially, here's the general purpose. What we're trying to do is we're going to figure out which groups of voters are needed to pass a motion. One of the things that you might realize is the higher or the more votes that a person has, the more likely they are to be part of a group that's a winning group, and therefore they have more power. So that's what we're going to do. We're going to look at how often each one is not just in a group that can pass a motion, but is a necessary part of that group. So for example, if in this case the first 2 voters vote yes, so the first 2 voters vote yes, yes, and these 2 vote no. No, does the motion pass? Yes. The motion passes 70-30. This is an example of a winning coalition, right? And in that particular case, both of them are necessary voters because both of them have to be there. If suddenly one of these 2 yeses were to change their mind to no, the motion would fail. However, if we look at these other two, these people that vote no, okay? Let's say this is a yes. This guy's a yes. If he's like, no, you know what? I'm going to vote yes on this motion. He's actually not necessary. His vote, his 15 votes don't really matter. Whether he votes yes or no, and whether this guy votes yes or no, does not actually matter. And that's important as well to see. Okay, so now let's take a look at how we're going to put this together. Okay, here's a situation as well that we can take a look at. So, European Economic Community for the years 1958 to 1972 had 6 countries that were voting members. This is a legitimate table, 17 votes. This was a group of 6 countries. Essentially, the way that it worked is like West Germany sent 4 people, Italy sent 4 people, France sent 4 people, Netherlands sent 2, Belgium sent 2, and Luxembourg sent 1. But the people from one country essentially voted together. So there were 17 people that were present, but like all 4 of the West Germans all voted the same way. All 4 of the Italy people voted the same way, and so on and so forth. Now, the quota for this system was set to 12. That means that a motion that they come up with or some sort of new rule that they want to create will only pass if they get 12 of them to vote out of the 17. Okay, you notice anything interesting in this table? Okay, you might notice that West Germany, Italy, and France can pass something completely on their own. 3 really big countries, Netherlands, Belgium, Luxembourg, not big countries. So if all 3 big countries agree, then good. We're good, right? It passes automatically. But what if they didn't all agree? So one situation that can occur is if 2 of these 3 agree, right? So let's say 2 of these 3 agreed. Let's erase this here. Okay, so let's say 2 of these 3 agreed. Let's say West Germany and Italy agreed on something and France did not. Okay, would the motion necessarily pass or would it fail? Not yet. We have to wait for these 2 to happen. So look at Luxembourg and so if we look at, say, Luxembourg and Belgium, right? Netherlands and Belgium right here. These guys can vote to make the motion pass anyway. They can overrule 1 of these countries, which is interesting. What they can't do is overrule 2 of them. So if 2 of these countries, Italy, France, and West Germany, if 2 of these countries vote a motion down, then there's nothing that they can do because the most then that they could get would be 9. So that raises an interesting question in case you happen to see it. Netherlands and Belgium together count as one of these, essentially, what's happening. But what about Luxembourg? Luxembourg only got a single vote. Kind of interesting, right? Because then, if you think about it, because these 2 can pass or fail the motion, Luxembourg doesn't really have much of an impact here. Luxembourg is the only one with an odd number of votes, and so they can never be the deciding 12th vote because you can't get an odd number beforehand. So their vote, no matter what the other people vote as, they'll never change the outcome of that motion, and they are what's known as a dummy voter. A dummy voter has 0% power because it's never necessary. Okay. A dictator is the opposite, a voter with so many votes that they control the outcome regardless of the other voters. Clearly, that's not happening here. Okay, so in a dictator, here's a system that has a dictator. If you had a system, let's say you had a quota, say if you had 14, 13, no, sorry, no, let's not do that. let's say you had a vote like this. You had 14 and you had, say, 7, 4, and 2. You had 4 voters that do that. But let's say the quota was actually only 12. Okay. This 14 controls the outcome. Actually, wait, no. Here's the situation. If we have this, and we have this situation, and this were, say, a 5. Okay, in this situation, 14, this guy has more than half of all the available votes. So the quota, 14 can reach the quota. So if he votes yes, the motion automatically passes. But what happens if he votes no? If he votes no, the other 3 people don't have 12 votes. They cannot override the 14. So in this particular situation, this 14 is a dictator, because what he says goes, and a dictator has 100% of the power. Okay. Now, that being said, there are situations, notice what we said here about these numbers. These guys here, these 5, 4, and 2, even though this guy has a ton of votes, if he votes no, right? There might be a way, if these guys had enough votes, they could override him. If he votes yes, that's it. It's automatically passed. But if this guy votes no, right? If these numbers were bigger, they could override the 14 and pass the motion anyway. So that might be interesting to think about. A voter with veto power has enough votes to stop a motion from passing, but they can't stop it from failing. So let's take a look how that works. Let's say you had a system like this. You had a quota of 20, okay? And you had values of, say, 16, and then you had, say, 11, 6, and 2. So you had this situation. So here's the thing about the 16. What happens if he votes yes? If he votes yes, okay, the other 3 people could band together and they could stop this motion from passing. They could stop him and be like, nope, we're not going to pass it. We're all going to vote no. And it passed, and it fails because he only had 16 votes. But what happens if the reverse is true? What if this guy votes no? Let's say this guy says, no, I don't want this motion to pass. The other 3 people cannot band together to pass the motion. When 16 votes no, it's dead in the water. So when this situation happens, we call this a veto power. It means that he has the authority to stop the motion from passing, even though he may not always have the authority to pass it. So it's an interesting situation, almost like a mother may I situation, right? And this always happens when you got one person who has a number or a number of votes that's already pretty close to the quota. Okay. So what we're eventually going to do, in between dummies and dictators, are actual voters vying for power. One way we're going to define this is the idea of called a critical voter. And that's what we said before. It's a person whose vote actually mattered. So let's look at this group here. We have 11, 6, 5, 4, 3, 2. Okay, so let's say we had this group. And the coalition of P2, P3, and P4, right? So let's say this happens. Let's say yes, 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 no. So P2, P3, and P4 all vote yes, the other two vote no. Now, does the motion pass? Yes, it's got 12 votes. So the motion would pass. However, what happens if one of them changes their mind? If any one of those three change their mind, that's it. You're done. Motion fails. Okay? So all three of those in that situation become critical voters because all of them were necessary to make that happen. Now, what if this guy over here, this no, let's say that he was a yes as well. Now, in that case, that too, he's not a critical voter because he wasn't needed to pass this motion. Yes or no, he wasn't needed. Same thing with this guy. Yes or no, he wasn't needed either. Okay, so what we're going to do is we're going to look at how many times a particular voter ends up being necessary. And that's going to give us voter power. Okay, this is going to be more about organization than about any sort of like hard math. Okay, so essentially what this is going to say is that we're going to turn everything into percentages. So let's just go ahead and take a look. Okay, let's try this with the system 13, 10, 9, 3, 1. So we have 4 voters, 10, 9, 3, and 1. So here's the idea. We want to write down every combination of voters that passes. P1, P2, P3, and P4. Okay, so we want every combination of voters that adds up to 13 or more. Let's take a look. So the most obvious case is they all vote yes. That's the most obvious case. The next case that can happen is what if, say, it's the first 3? Or maybe it's the first, the second, and the fourth. What about the first, third, and fourth? That works too. What about the second, third, and fourth? That one works too. So all combinations of 3 voters is also able to pass the motion. Now, what happens if there's only 2 voters? Well, P1 and P2 can pass by themselves. P1 and P3 can pass by themselves. Now, P1 and P4 can't, nor can P2 and P3, or P3 and P4. So in this particular case, there's exactly 7 combinations. These 7 combinations represent the voters that can pass this motion. What we want to know is, were all of these people necessary? Okay, so let's first off, pretty clearly, if we look at these two over here, these guys were all necessary. Like in this group, 10 and 9, they're both necessary, right? Without each other, the motion doesn't pass. So we're going to underline those, and we're going to say that all of those voters were necessary in those instances. Okay, so in each situation, let's say all 4 of them vote yes. Okay, so let's erase this here, and just for clarity's sake, okay? Let's say all 4 vote yes. Were all of them actually necessary? Well, the 1 certainly wasn't necessary. The 3 isn't necessary because of the 10 and the 9. The 9 itself isn't really necessary because if you have 10, 3, and 1, it still passes. And even the 10 isn't necessary because the other 3 can override him. So guess what? None of these, even though when all 4 vote, none of them are actually necessary voters. One of them can drop and still win. And that's evidenced by the fact that all 4 of those combinations are here. So now what we're going to do is we're going to go through in turn, and we're going to see in this particular situation, in each of these situations, are the voters necessary? So what we'll do here is we'll look at this and let's say, well, I've got 10, 9, 3, and the one vote no. Okay, so 10, 9, and 3 are those voters necessary? The 3 is not. The 9 is not either because the 9, 10 and 3 would be left, so that one is not critical either. But the 10 is a critical voter because if the 10 drops, and we already know that the 1 voted no, then the 9 and the 3 cannot pass the motion. So in this situation, the 10 is what we call a critical voter. Okay. Now, we're going to go through each one in turn. Okay. So 1, 2, and 4. So the group of 1, 2, and 4 are all 3 of those critical voters. Okay. The 10 is definitely critical. Without that, it fails. The 9 is definitely useful because 10 and 1, but the 1 is not. So we're going to underline the first 2 here. Okay. All right. And then we're just going to keep doing this. We're going to now cross out the 9. And we're going to say now 10, 3, and 1. The 10 is necessary. The 3 is necessary because 10 and 1. The 1 is not necessary. Without the 1, you'd still have 10 and 3. Okay. So those 2 are critical. The 1 is not. So you see what's happening here. The 1 really isn't a factor at all. Okay, what about 2, 3, and 4? Now we're going to cross out the 10. What if the 10 wasn't there and it was just 9, 3, and 1? Are all of them necessary for that motion to pass? In this case, all of them are necessary because even the 1 would be that tie-breaking 13th vote in that situation. Okay. Wow, that's a lot of organization, okay? So this is kind of what has to happen. We're going to look through and we're going to add up all of our critical voters. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 criticals. Okay. How many times does P1 appear? P1 appears 5 times. P2 appears once, twice, 3 times. P3 also appears 3 times. And P4 appears once. So what I'm doing to get these is I'm counting the number of times I've underlined P1, the number of times I've underlined P2, because those are all the times that they were a vote that was necessary to decide the election. Okay. So 42%, 25, 25, 8%. So in other words, what this basically says is that P1, when they cast their vote is going to be a deciding vote 42% of the time. Their vote becomes necessary 42% of the time. That means that that's a good power. Whereas P4, only 8% of the time will it be a deciding factor. Okay? That's really how this gets done. And one thing you might be surprised about, look at P2 and P3. Okay? This is where you might see the most surprise. They have equal power. Equally, the second voter and the third voter are a factor 25% of the time. But look at this. They have separate weights. P2 has 9 votes, yet P3, even with only 3 votes, the same amount of times. And the reason has to be, the reason why this is happening is because both of these separately, the 9 and the 3, either one of those combines with the 10 to get to 13. Remember that we don't need to hit exactly 13 or any number particularly more than 13. We just have to get to more than 13. So whether we get 19 or 13 itself doesn't matter. Both cases we've won. That's why these two tend to share power. So that's an interesting thought. Okay. All right. Well, that's kind of a lot of information. We can go through um, one more problem real quick. I'll just kind of show this one to you, so not to make the video terribly long. Here's another situation. Um, yeah, we can do this one out. Really, it's the same one, right? It's actually in here twice. Okay. Um, so in this particular situation, you have 10, 7, 7, and 4. The quote is 16. So the first thing that we do is we write down all the groups that can pass the motion. And in this case, you're going to actually notice that it's the same combination of voters. All 4 can pass this. Any group of 3 of them can pass it. And then P1 and P2, and P1 and P3. And then from there, you figure out when each one is a critical voter. So in this situation, let's say, like we look at, again, if you have all of them, if all of them vote yes, then none of them are actually necessary. Any one of them can freely drop and still pass. Well, let's look at P1, P2, P3, right? So again, same idea here. We cross out the 4. And then we wonder, what's necessary? Is the 10 necessary? Yes, because 7 and 7 only give you to 14. But the 7s, each of these 7s separately can be dropped. So P2 and P3 are not critical voters. Either one can drop, and the motion would still pass. But it's when you get to situations like this, like P1, P3, P4. In that case, both P1 and P2 are necessary to that group. But P4 is not, because you can drop the 4 and you'd still have 17. So those are the things that you kind of have to think about. And the one thing you're going to notice here is the breakdown is exactly the same as the other problem. That will happen a lot. And notice here, equal votes, equal power. So yes, if you have equal votes, you have equal power. That's a guarantee. But the reverse is not. Equal power does not mean equal votes. Okay. So although this is a coincidence that you get the same answer, a lot of times that will happen. So do be on the lookout for that. Okay. All right. So this is just kind of going over a couple examples of how to calculate voter power. I hope this made kind of sense. And just as a way to freely explain it a little bit more if you need to. Okay. Have a good day, and I will see you in the future.